Hello everyone. Here I would like to solve several examples about recursion. But first, let's clarify what the recursion is in terms of programming. Recursion is a concept where function calls itself when solving a problem or a task with a smaller version of that same problem until it reaches a base case, or in other words, stopping condition. So, in other words, or in simpler words, recursion makes function to call itself until the parameter value in that function is either 1 or maybe 0. So then we can return the value of it, and then we can add something, multiply something. So in order to understand it better, I'm gonna solve some several examples. So in the first example, I'm gonna just ask the user to enter any integer number, let's say 7, and I just wanna uh, add all the numbers between 1 and 7 and get the result of that addition or summation, which is gonna be uh, 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15, 15 plus 6 is 21, and 21 plus 7 is 28. So how to do it in the Python by using recursion. And by the way, why I'm using recursion or why I don't use, let's say, for loop or while loop, because recursion is really, effective approach to solve some sequence with the numbers. So you see the sequence 1, 2, 3, 4. So that's why it's useful. All right, so let me write it the code in Python format. So let me call the function as well as some numbers. There is a n variable as a parameter for that function, and I'm checking if the number n is equal to 1, then return 1. First of all, let me write the code, and then I'm going to explain step by step. And by the way, this is a base case, which is a stopping condition. Else, or in other words, otherwise, return n plus some numbers function. You see, I call the function again in the function itself, n minus 1. And then consequently, I'm gonna proceed to the main scope of the program. Result is gonna be some numbers, and I'm gonna pass the number 3 into the parameter as the parameter for the sum numbers function, and print the result. All right, so here is the base case where it is obvious which number to take, 1. But if I have number which is more than 1, which is 2, 3, 4, 5, let's say I'm gonna have 3 in this case. So 3 is not equal to 1. I'm checking if 3 is equal to 1. Is it? No. Then I proceed to the else statement, and I perform or execute following instruction or expression. So n plus some numbers n minus 1. In other words, 3 plus some numbers. 3 minus 1 is 2. Okay, let's cross the line, vertical line, to distinguish between the addition and functions calls. So I have some numbers right now. So I have to perform this function call again. So right now the parameter value is 2, and I'm checking in the if statements. Is 2 is equal to 1? No. Then I jump into else statement again and perform the following expression. So 2, in this case n is 2 plus some numbers. 2 minus 1 is 1. So crossing the vertical line to distinguish, and I have a value 1 in the parameter, and I'm checking in the if statement again. If 1 is equal to 1, then return 1. By the way, this is a base case, which is if statement, and else statement is called complex case in terms of definitions for you to know. So 1 is equal to 1, so return 1 here. And why I cross the lines? Because I want to distinguish between the numbers and the functions calls. So something like that. 3 plus 2 plus 1 is 6. And I'm gonna get 6 as a result. All right, that was the first example. Let's apply the second example, which is similar to actually to the second example, but just in terms of multiplications. There is a special word for multiplication between the numbers, sequence of numbers. It's called factorial. I'm sure you know it. For example, let's say 5 factorial. Exclamation mark performs or represents the factorial meaning. So it's gonna be 1 times 2 plus 3 plus times 4 times 5, which is gonna be 120. By the way, there are rules in mathematics that 0 factorial and 1 factorial are both equal to 1. So we have to mention them in the base case as well. So def factorial n. Maybe, yeah, just n, let's call it again. So if n is equal to 0 or n is equal to 1, then return 1, obviously, because their factorial um, answer is going to be 1. Otherwise, return. It's kind of similar to this expression. Just instead of plus sign, we enter the multiplication sign or asterisk operator. Factorial n minus 1. But why n minus 1 actually? Why n minus 1? Because it's the sequence of numbers. If it was n minus 2, it will be, in this case, it will be like this 1 times 3 plus times 5 times 7 times 9 and so on. It's not what we want. We want the sequence of numbers. How? Just by writing n minus 1, not n minus 2 or n minus 3. So this is the base case. This is a complex case. All right, so result factorial. Let's apply number 4 for this case. So print result. So as a parameter value, I'm gonna have 4 here. So I pass that 4 to the parameter for the factorial function. Then I check the if statement. If 4 is equal to 0 or 1, it's not correct. Then I jump into the else statement and I perform this expression. Yeah. So 4 times factorial n minus 1. 4 minus 1 is 3. Then it's going to be 3 times factorial 2. Then it's going to be 2 times factorial 1. And by the way, since as soon as we get 1 here, we still have to check the if statement. If 1 is equal to 0 or 1 is equal to 1, this statement is true, then we have to perform this expression 1. All right. And we just simply product all together. So 4 times 3, 12, 12 times 2, 24, so 24. So in this line, the result is going to be shown as 24. And let's solve one more common example, which is Fibonacci sequence. Let me explain you the rule of Fibonacci, such as um, and so on. You may know or you may not know the algorithm, how do I distribute or why do I write these numbers exactly like this. So we have an initial point as 0 and also initial point as 1. Okay, so now here in this point starts the Fibonacci sequence. How? I take the current value 1 and I add that current value with number 0. So I get in this new upcoming index or upcoming value number as 1. All right. Okay. Now I'm in the number 1 and I have to add them together. The current value with the previous value. So I'm gonna get number 2. So the current value is 2. So I add that current value with the previous value, which is 2 plus 1, 3. 3 plus 2, 5. 5 plus 3, 8. 8 plus 5, 13, and so on. 13 plus 8, 21. All right. So if n is less or equal to 1, return the number itself. Otherwise, return Fibonacci n minus 1 plus Fibonacci. As you can see, I call the function twice in one statement, n minus 2. And then I store the result into the result variable. Let's give an example as 5 in the parameter and print result. Okay, let's solve it by step by step. So I have 5 in the parameter here, and I check no if statement is not executed, so I jump into else statement and write this expression. So Fibonacci n minus 1, which is Fibonacci. Actually, let's make it like a classification, hierarchical classification. I have 5 in the initial point, and I perform this line. So it's gonna be, there are gonna be arrows, Fibonacci n minus 1, which is 4, and n minus 2, which is 3, because 5 minus 2 is 3. All right. Now I do the subclassification again. So Fibonacci. So since I have function Fibonacci 4, I have to perform the statements again. If it's not correct, so I jump from the if statement to the else statement and perform the following expression again. So Fibonacci 4 is going to be Fibonacci n minus 1, which is 4 minus 1 is 3, and plus Fibonacci 4 minus 2, which is Fibonacci 2. And by the way, don't forget that there is a plus between them, but it won't affect actually our solution because we still don't get the obvious values. You see, we still work only with functions here, here, here. So I don't prefer to actually write the plus sign. I'm gonna write the plus sign when I'm gonna get the obvious values from this if statement. So Fibonacci 3, Fibonacci 2, and in this case, what are the parameters values? Fibonacci is gonna be 1, not 1, actually it's 2. And here is gonna be Fibonacci 1, as far as I understand, right? Is it correct? Here is 3, here is 2, here is 2, here is 1. Okay, so here is gonna be 2, 1, Fibonacci 1, Fibonacci 0. What about here? 1, here it's 0. All right, that's it. Actually, it's not a finish point yet because we have 2 still. All right, now let's take green color to distinguish between the numbers between the functions, okay? So since we get 1 or 0, we perform the if statement in this part of the code. And whenever or whatever the value of n is, we're going to return this value. So Fibonacci 1 is going to be 1, 0. So what functions are in the result? This one. So whenever I add all of them together, 1 plus 0 plus 1 plus 1 plus 0 plus 1 plus 0 plus 1. In total, I'm gonna get 5. So what does that mean? When I pass 5 into the parameter for the function, it means that I take index 5. So index 0, 1, 2, 3, 4, 5. And I wanna know what the number is under the index 5. So result is gonna be 5, this number. But let's say if I pass the number 7 into the parameter for the Fibonacci function. So 7 in this case would represent the index as well. And in the result section, I would get 13. If I passed, for example, number 8 into the parameter for the Fibonacci function, I will get 21 in the print section. So that's how we use recursion. Let me remind you that it's really useful when we solve some sequential tasks where the sequence is important. Like you see, there is a sequence of numbers 1, 2, 3, 4, 5, addition, multiplication, and also here you just have to add the value of the current value with the previous value. That's also the sequence of numbers. So that's how it's useful to use the recursion.